All right, so let's talk about data types in R. So we want to talk about different data types in R. So in short, we're going to have 9 different data types. It can be integer. So any numbers is integer, right? 1, 2, 3, 4. It can be double, numbers with decimal. It can be character, like hello. It can be logical. Logicals are true, false, right? Then I scroll down. It can be vector. We can have a vector of numbers, vector of names, and etc., right? Then scrolling down, it can be matrix. I guess all of you guys are familiar with matrix. Then we scroll down, it can be factors. Factor is something specific to R. So for instance, if you're familiar with Python, we don't have something like something like this in Python, but we're not going to use factor in this course specifically, so I'll quickly go over the factor. And again, I will emphasize what you need to take away from this R script, by the way, because not necessarily you need to understand all of it, but it's a good idea to learn them because it's kind of they're the very basics of R, and you should know them in general. So maybe we don't use them in this course for econometrics, but when you're using other people's code, if you want to read comments in Stack Overflow and they say that, okay, this is a factor, this is a matrix, this is a data frame, you should know what are these things, different data types in R. So the 7th one is factor, then the 8th one is data frame. By the way, data frame is the thing that we're going to work in this course, right? In this course, we're going to download the built-in data frames in Bouldridge package, and simply we just call the name of the data frames, and that's it, we're done. But again, I highly recommend you to learn what are all these different types, vector, factors, and etc. And finally, we have, I think the 9th one is down here. It's at the very bottom is going to be list. So list is literally list of, it can be, it's a generic collection of objects. So the objects, it can be, list can contains all of those 8 different objects that we already talked about. At least we already named it. Okay, so let's start with the first one. So the first one is the easiest one, integer. So an object can be an integer, right? And let's make a deal. Let's make an arrangement here. So in the console, I want to generate a variable. I want to call it x, right? Let's call variable x, or let's call it variable y. If I write y equals 10, there's nothing wrong to defining y equals 10 like this in R. So if I press enter, before doing that, I want you to look at this environment. When I press enter, look at the environment, what will happen. So I just press enter. In the environment, there is this new y, right? It says that y is equal to 10. And 10, it's a number, right? So I can generate y like this, or I can generate z. Instead of equal, I can write, do it like this, equals to 15. So in R, we tend to use this symbol for instead of equation, and there are lots of reasons to do that. But basically, remember, it's easier to follow to assign some values to an object like this. To read it like this, I'm assigning 15. Think of it as an arrow to the left, right? Take the 15, assign it to z, and when I press enter, look at the environment, z is equal to 15. Again, you could have written z equals to 15, but I want you to get used to do it this way. 15 is assigned to z. So instead of doing y is equal to 10, I really want you to get used to do it like this. Assign 10 to y. The reason is that we're going to use equality within the functions. So in order to ignore that confusion, we want to make sure that whenever you want to assign something to an object, use this symbol. Whenever you want to set the parameters value in a function, we are going to use equality, right? I hope that's clear. But again, you will see tons of examples that you realize why we use this thing in R. And it is R specific. In other languages, we don't have something like this. Okay, so let's clear the console. And do you see that here I have X, Y, Z? So this is my environment. If you want to clear your environment, there is this map here. You click on it and ask, are you sure you want to erase all the variables? You're going to say, okay, yes, go ahead. So the environment is empty. Okay. Okay, so now you should be able to read this line very quickly. We are assigning number 2 to x, but what is this L? So L, if I put L here, then I'm telling R that this is integer. So this is 2, it's not 2.0, it's 2, right? So when I write this line, look at that. In the console, it says that assign integer 2 to x, and then if I call x, just typing x, if I call x, it says that it's 2, right? If I call x plus 5, if I do x minus 2, does that make sense? The answer is going to be 0, because x is your variable, right? So let's clear the console. So running line 11, x is 2. Then when you have a variable here, you can do some stuff with that, right? And how do we, so for instance, you can see what is the type of that variable. So, and we read it like this. Whenever you see there is a word and then open close parenthesis, basically you're calling a function. So this is a function. Type of is the name of a function. So I'm literally asking R that what is the type of x? So if I run this line, look at the look at the console, it says that the answer is integer. So x is integer. Then I can call many different functions here. I can say I'm asking R so this is a name of a function. There's a dot here. Is integer, so what do you expect to see as an answer? The answer can be true, false, right? So if I ask R that if x is integer, the answer is going to be true, right? So you may wonder that, okay, how do I know that this type of, why it's not capital T, why it's not type dot of, and for instance, why this is dot integer, why it's not is integer without a dot. Okay, so these are very good questions, but remember, the reason is, so these functions has been written by some developers. So for instance, in the ones who are working for, who are developing packages for R, and the author of that package wanted to use this name for his or her function. The answer is that simple. If you write your own function, you could have named it anything. Remember, I told you, we are borrowing functions from different people in our community. But the point is that these functions are very well known, that everybody knows that. For instance, if I write sum, it's a summation function. If I write, does it make sense? So I don't do, for instance, sum. R doesn't understand this kind of sum. I have to write it in small letters, sum. Okay, and etc. Right? So for instance, then what else? Let me see. All right, so that's the first type of the object, integer. The second one, double. So if I do not use this letter L, basically my variable is going to be double. And double basically is some number of decimals, right? So I want to say that y is equal 2.5. Now let's go ahead and run this line. So y is equal to 2.5. You see there is no L here. And then I can ask this question, is y double? If I run this line, control enter, the answer is true. Then look at that. So I'm in the console. If I press multiple enter, it really doesn't matter. I'm just scrolling down. I can say, okay, now you know what is x is an integer. You know what is y. Can you tell me what is x plus y? Right? X plus y is going to be, it's going to be a double, right? Because it's 4.5. So integer plus a double, the output is going to be a double. And so you can do different. So these are basic operations. Multiplication, summation, addition, subtraction, multiplication, division, and etc. That's basically as if you're using calculator. Okay, so the first two are clear. Then the third type is character. We already talked about the character. So let's say I want to save the word hello in an object and name it A, right? So let's look at that. If I run this line, look at your environment. The environment A is now a variable and it has a character. So this is a sign of character, quotations, character in it, and it's hello, right? Now, let's call it function type of A. So if I do type of A, the answer is going to be character, right? Okay, one last thing. Do you remember I told you that you can use a console as a scratch paper? So it really doesn't matter if I use two quotation, test, or if I just do one. Both of them are going to be character. You see, either you use two of them or one of them, both of them are going to be treated as character. Okay, just for your information. Okay, the fourth one, logical. So sometimes you are interested to save the true and false values in a variable, right? So I want to say that, okay, x1 is true, x2 is false, right? So if I run this line, then x1 is going to be a true variable and x2 is going to be false. And the reason that I did it this way, because either way, if I in R, if you either use capital T or you write it true or you write it this way, all capital letters, all of them are treated the same. F, capital F, or writing literally false are the same, right? So let me show you an example. So for instance, if I start typing false, sorry, capital F, false, see, it suggests me that we have a false for that, right? And then they're all cap letters. So let me do it in a console. It makes more in an editor. So let's say, for instance, x3. Again, a good way for you guys to practice this thing is rewriting. Do not run these things from on my code. Just rewrite them in a blank piece of R script and try to replicate every single line, and then you get the idea of what I mean. Because RStudio, as you type things, is going to help you out. So if I write true and wait a minute, then it will suggest me that it should be all capital letter, right? Oops, my computer is freezing, I guess. I don't know why my mouse is not working. Anyways, so if I write it true or capital T, you see that the color changes. So when I do TR, the color is black, so it's not a reserved name, but T is reserved. Look at the color, it's bluish. True is reserved. So F is reserved and false is reserved. Does that make sense? And so why do we care that something is reserved or not? Because at the end of the day, sometimes you want to give a name to your variable. So this is not a good name for your variable because this thing has already been reserved in R as a true statement. So it's not a good name for your variable. So, but x1 is perfectly fine. x2 is fine. A, fine. X, Y, fine, right? So these are the logicals. What are the logical operators? So the operators are, you're all familiar with greater than, less than. For equality, if you want to check if something is equal to something else, you have to use two equal signs, right? So, and this is for not equal, and then again, we can have or, and. This is a function, is true. For instance, we say not equal not, so this is not, negative, negative, positive. Again, we are not going to deal with these things in our course, so don't worry too much. But remember, these are the very basic stuff in R, and I believe you should know. But can you survive the course without knowing these things? Absolutely. I hope you get the idea of what I'm trying to go with this argument, that what you should know, what you should not know, and don't get confused. Without knowing any of them, you can survive in this course, because at the end of the day, what we do in R is going to be, I don't know, 4 lines of code, and that's it. But if you ask me what is the proper way to learn R, this is my answer. You have to do it this way. Okay, now let's see. Let's use the console and talk to R and ask some question. I want to ask R if number 4 is equal to number 4. It sounds stupid, but this is a correct statement, right? So if I do something like this and press enter, R understand what I'm talking, says that, oh yeah, that's true. If I say, okay, R tell me if 4 is not equal to 5. What is the answer to this one? It says, yes, 4 is not equal to 5, right? And sometimes I want to save it. So I want to save it and give it a name. I want to call it x. And I say, so 4 is not equal to 5. The answer, I know that the answer is going to be true. And true is going to be assigned to x, right? Remember, in my x variable, there's already an integer, 2. And remember, this L stands for integer. So there's already something on it. If I run this line, it's going to override this x, which is 2, with true. Does that make sense? Hope you're following. So when I run this line, look at the environment. You see, it override the 2 with true. Then I can ask question, is true? No, again, these are functions. I'm asking if x is a true statement. The answer is yes, so it's true. And then I can say, again, these are, I know 4 less than 5. Is it true? Is it true a statement? The answer is yes. Then I say negate that one, not yes. So it's going to be false, right? Again, let's not make a big deal out of it, but these are the logical operators. If you have seen them before, it's easy peasy. If you haven't, again, you're seeing it now. And so we can look at some things here. So for instance, the answer to y is going to be false. Play around with these things, okay? The next object is going to be a vector. So this is very important. So from this part down the road is going to be important. I really want you to understand them very clearly. So next type of data object is going to be vector. And for vector, we are going to use a function, and that function is called C. Remember, in R, if I have anything, let me clear the console. If I have anything comes with open close parentheses, it means that this thing is the name of a function. So now if I press enter now, definitely R is going to complain. It doesn't understand. It says that, what are you talking about? Cannot find this function. There's no function with this name. However, if I write the name of functions that are well-known functions like C, it's a function, and C stands for combine. Basically says that combine whatever is inside this parenthesis. Now if I press enter, well, it said the answer is null because nothing is there, right? So I say, okay, combine 1, 2, 3, 4. If I press enter, see, this is going to be a vector. This is going to be a vector, and in that vector we are going to have 1, 2, 3, 4. I can say combine 4, 5. So this is going to be a vector. In that vector I have 5 and 6. Right? Does that make sense? So let's look at this one. So now that you know what is C functions, so let's use C as a function here. So line 46. This is so I can have a vector this way. I can have a vector using another function. So for instance, another function is, one of the most useful functions called seq. S-E-Q stands for sequence. And again, as soon as you start typing things, RStudio is going to help you out with some suggested functions. So, and if you were ever wondering what are the names of the functions, there's a help button here. You can press help and then do seq. Oops, sorry, not here. Here. Sequence, and then press enter. And there's documentation here. It says that it's a sequence generating function. There's a description, and always in the help in the RStudio, if you scroll down, there are some examples. So you can copy and paste these examples in the console and see what's going on and then play around with them. Okay. But in my opinion, I personally very rarely use this help button because I use Google. So if you don't know anything, any of the name of these functions, just Google it. So what is a sequence? And we are going to cover some of the very useful functions in R. So that's the idea. We say that give me a sequence of between 1 and 5, right? So it starts from 1, 2, 3, 4, 5. So if I do sequence 1 and 5, if I do sequence 1 and 10, you get the idea. It will give me the sequence from 1 to 10, right? I could have generated this with something like this: 1, 2, 3, 4, 5, 6, 7, 8. Does that make sense? So in order to avoid typing all that thing, now I just use a sequence function. Okay, so that's a useful function. And then You in that sequence function, there are usually inside the functions you can play around with the function features, right? So look at and in the documentation you can see what are the functions. There's a from, the first argument is from, the second argument is to, the third argument is by what, by how much. This is the length of the sequence. So let me give you an example. So sequence of, let me give me a sequence of from 1 to 10 by steps of 2, right? So it's 1, 3, 5, 7, 9, etc. So this is what we're having here in line 48. I'm running line 48. Then you can say, give me a sequence from 1 to 10th and make it into 100 pieces. So I run it. So it's going to be 1 to 10 and divided into 100 pieces. This is the sequence we get. Does that make sense? Okay, hopefully. Again, you have to play around with these things. And we are on line 50. Now we're going to say that, so for instance, what if I put a number and a string, a character, into a vector? So what will happen? So if I run, and by the way guys, if I highlight some part of the code and press Control Enter, it's going to only run that part. Okay, it's as if I'm typing this one in the console. You see, without typing it, I just highlighted and then press Control Enter. So I just wanted to, this isn't, sometimes people make mistake. If you're combining a character with a number, R doesn't understand that all of them are, so the first one is character, the rest of them are number. It's going to coerce all of them to characters. You see, it's character, 2 is a character, 3 is a character. It's not integer anymore. So be careful about that one. All right, so there's the next function is replication. So repeat 1 3 times. So this is how you read it. Repeat the first element how many times? So repeat 1 3 times. Repeat, you can repeat a character multiple times. Padram. Repeat a vector. Remember, it's a vector of 1 and 0 5 times. So 1 0 1 0 1 0 1 0 1 0, right? Repeat a vector, but each of the elements of the vector 5 times. 1 1 1 1 0 0 0 0. Okay, so I'm gonna speed up here because you get the idea. If you have, so for instance, you're wondering how can I know that this is something like this? Just Google it. Let me give you an example. How can I repeat numbers in R? Stack Overflow. I personally, do not memorize the name of any of these functions. Some of them, yes, I remember because I have used them thousands of times, but in general, I don't memorize anything when I'm coding. So Stack Overflow, you can just quickly look at what's going on. So repeat rows of data frame, create sequence of repeated values in sequence. Yeah, this sounds fair. So let's do that. Click on it. And then you find that there's a repeat thing. So usually people ask questions, say that, okay, how can I do something like this? And then there are answers here. So there are 3 answers. Well, see, the first one, 79, the second one, 157. So most probably this is a better answer. And what is the function? Repeat from 1 to 5, each of them n times. So n can be any number, 3 times, 4 times, 5 times, etc. Right? And this is the one that we use. Remember, repeat from 1 to something, and each one 20 times, 5 times, etc. So this is how you Google it. That's what I mean. My point is that don't get lost in any of these functions. It's literally, you have to just, if you don't know anything, just Google it. All right, there is another very useful way of creating a vector, and which is by using a column. So if I do 1 column 5, so we will generate a vector of 1 through 5. So I can do it 3 different ways, right? I can do it C 1 2 3 4 5, right? I can do sequence 1 through 5. So these are different ways of generating exactly the same thing. All right. The next thing that I want to talk about are brackets. Brackets are used for extractions. and it's very important and it's very useful. So let's make a variable, call it x, and then in x we're going to put a vector of 10, 20, 30, 40, 50, right? So let's run line 61. So this is my x. You can always look at what you've done in your console. So if you just write x and press enter, you see, so it's a vector of 10, 20, 30, 40, 50. What if I want to extract the second number? What if I want to extract the last number? What if I want to extract the first three number, right? So there should be a way to do that, right? And for in R, we're going to use brackets for extractions. So for instance, I want to see what is the second number. I just do x, the name of the variable that you created, open close bracket, and then give me back the second variable, second object, 20. Give me back the fourth object, 40. Now, so we can play around with this bracket. So let's see what are the options. I will say that give me back -1 and see what we'll get. So how should I read that? It tells me give me everything except the first element. Does that make sense? So the first element was 20, gave me everything except the first element. Give me everything except the third element. So what do you expect to see? 10, 20, third element is not, 40, 50, right? And we can have more fun with extractions. So for instance, I can say, give me the first element through the third element. Does that make sense? First through the third, 10, 20, 30. And what else? We can say, okay, for instance, give me a combination of elements, a combination of the second element and the fifth element. What do you expect to see? 20 and 50, right? And what else? So we can say, we can be even more specific. R is very flexible. We say, give me a combination, and in that combination, do not give me the first one, do not give me the third one. Oh, sorry, do not give me the third one. Does that make sense? So 20, 40, 50. Okay. So these are different things that we can do, and you can see a bunch of them here from lines 61 to 69. Again, extraction is very useful, and for example, even if you're using some functions from other people, but sometimes you want to reach out to a specific element within that function, so we have to use brackets for extraction. All right, so what are the vector arithmetics? Oops, there's a typo here. Vector arithmetics. Let's say we have two vectors, vector A and vector B. Let's look at the vectors. So let's write, so this is my A, this is B. So A is 1 through 3, B is 2, 1, 5, right? If I say A plus B, I'm running line 47, 40, sorry, the other way, 74, 75, 76, and etc. Okay, 74. So what do you expect to see? It's going to add the attributes, the elements of the vector, element by element. 1 plus 2, 3. 2 plus 1, 3. 3 plus 5, 8. So if I run this line, what do you expect to see? 3, 3, 8. If I run the next line, you know, this is really interesting. I'm literally communicating with R. I'm saying that A is greater than B. I'm asking that question. What do you expect to see, by the way? Pause the video for a second and think about it. I'm asking if A is greater than B. So remember, the vector arithmetic is going to be element by element. So it's basically say, if 1 is greater than 2, the answer is false. 2 is greater than 1, the answer is true. 3 is greater than 5, the answer is false. So what do you expect to see? False, true, false, right? Then I can do division, A divided by B. Just make sure that it makes sense. A multiply B. Okay, so this is vector arithmetic. Okay, the sixth type of the data set, data, which is matrix. So let's make a matrix together. Do you remember I did it in Stack Overflow how to make a matrix in R? Okay, so the function is called matrix. Remember, again, we have something, open close brand, it means that this must be a name of a matrix, right? So if I write matrix, see, it already suggests open close brand. So for now, there's nothing in it, but we're going to put something in this matrix and then give it a name, right? So that's the plan. So let's say, no, I make a variable, I call it my data, and then run it. So if I want to see what is inside my data, so just type my data or just highlight it, double click, and choose Control Enter, and that's it, 1 through 20. So this is my data, right? Now, as of now, this is a vector because we generated a vector from 1 through 20. But I want to transform this vector to a matrix. So to do that, I'm going to use a function called matrix. Then the first attribute of the function of the matrix is give me some data. I say, okay, the data is my data. And then what are the other elements? Look at that. RStudio is already helping you. Data, then the second attribute, number of rows, third attribute, number of columns. So I want to put this 20 the numbers into, let's say, number of rows. By the way, you can either type it and say equal or without typing it, because by default R knows that the second element is the number of rows that you're talking about. The third element is the number of columns. So if I do something like this or like this, it really doesn't matter. R understands what you're talking about. Okay. So what happened here? Look at that. I say that, okay, take this matrix, 20 numbers, and take this vector, give me back a matrix with 4 rows, 5 columns. Look at that, 1, 2, 3, 4 rows and 5 columns. See? All right. So we're going to make a matrix called, and you can assign this thing to a matrix called A. So this is basically what we're doing here. So let's make a matrix. So let me erase this one. Let's make a matrix, call it A. Look at the A. This is our A. Let's make a matrix, call it B. Look at the B. This is B. And the difference between A and B is that in B we are using an extra attribute of a function, and which is that we say, okay, by row is equal to true. If I do by row is equal to true, the matrix is going to start by row. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But by default, it's by column. Look at that, 1, 2, 3, 4, 5, 6, 7, 8, and etc. Right? So matrix, I have two matrices now, A and B. So guess what? We are going to do some extraction and then some arithmetic operations, right? So that's what we do with matrices. So for extraction, it's really straightforward. It's as if you're writing stuff on a whiteboard. So if I want to, for example, extract this element from your calculus, so how do I write this element? How do I extract an element like this from a matrix? The row is number 1, the column is number 2, right? So if I do something like this, A, open close bracket, remember we use bracket for extraction, first row, second column, the answer is going to be 5, right? So if I press enter, 5. Let's extract this one. From matrix B, 4th row, 5th column, the answer is 20, right? And now let's look at some more advanced examples here. So for example, I say that, okay, give me, from matrix A, I leave the rows blank. So I don't write anything. And by the way, it really doesn't matter how many spaces you put here. I understand, as long as there's nothing here, it's a blank. So so for number of rows, I put it blank. But for columns, I say that, okay, give me, I don't know, for example, the first column. What do you expect to see? I'm going to matrix A, give me the first column, all the rows, because I didn't specify the exact row here. Does that make sense? So 1, 2, 3, 4, 1, 2, 3, 4. This is how I extract the first column of a matrix. Then again, you can say, give me the row number 3 and number 4 for column number 2. So what do you expect to see as an answer? Pause the video and think about it. So row number 3 and number 4 and column number 2, right? So we are expecting to see 7 and 8. Right? So this is how we extract things from a matrix. All right. So whenever your object is a matrix, you can call some specific functions. For instance, if it is vector, you can call some function. If it is a matrix, you can call some specific functions built for matrices. So for instance, one of those functions, or again, for example, it's call names. So what is call names? Call names is basically column names, and column names if I'm telling R, what are the column names of matrix A? It's going to tell me that there's nothing, you didn't name them, right? So let's name them something. I say, okay, call names A, and I want to assign, so how many columns do I have? 1, 2, 3, 4, 5. So I want to just give them some name. Remember, because they are named, they're character, you have to put it in quotation. So it call 1, call 2, and etc. Right? So this is one way to do that. Call 3, call 4, and call 5. Now, if I call back the call names of A, of course, it's going to be, oops, call names of A is going to be the one that I just generated. Now, if I call back matrix A, look at that. Matrix A, this has column. Call 1, call 2, call 3, call 4. I can also give the row names. See, row names. I can specify the row names exactly in the same manner, right? I can erase the call names. I can say, okay, call names, I don't want to, just want to take it back. I don't like those names. So if you want to do that, say, okay, R, assign null to call names for me. Just ignore them. Now, if I call A again, oh, the names are gone. Okay. So this is what we're doing here, call names, none, and etc. So some specific functions for matrices. We have R bind, C bind, row names, call names. Again, so we are combining the rows, we're combining the columns, etc. If you're curious, you can always look for what is R bind doing, what is C bind doing. Yeah, but I just leave it there for here. You can have some extra fun with them. Try to Google them and see what does R bind and C bind do. And let me know if you have any questions. So operators in matrices. Okay, so let me quickly show you what is A, what is B as a reminder. So A, B. If I do A divided by B, it's going to be elements by elements. 1 divided by 1, 1, 5 divided by 2, 2.5, and etc. Right? So let's see what is the answer. 1, 2.5, 3. Multiplication, the same thing. Element by element. 5 multiplied by 2, 10. However, from your calculus, we know that matrix multiplication is different. Sometimes you want to multiply matrix A to matrix B. So in this example, our matrix A is 4 by 5. 4 by 5. Our B is 4 by 5. So I cannot multiply them by each other, right? So I cannot multiply A to B because one of them is 4 by 5, the other one is 4 by 5. So I can transpose B, make it a 5 by 4, and then do 4 by 5, multiply 5 by 4. The answer is going to be 4 by 4, right? So how do we transpose a matrix in R? So you just simply call T open close paren. So transpose B. Again, why it is T? Because the author wanted to call it T. And why we are using it? Because it's very well known. Okay. So this is a transpose. So let me show you actually A. So this is A. I can look at the transpose of A. You see, 4 by 5 transpose is 5 by 4. Now I can multiply A by the transpose of A, right? So what is the matrix multiplication? A, if I do something like this, I'll get an error. Because it's trying to multiply elements by elements, right? If I see, I'll get an error. Because yes, there's an element 1 by 1, but this is 4 by 5, this is 5 by 4, so it cannot multiply element by element. However, I can do matrix multiplication. How do I do matrix multiplication in R? So I have to use percentage sign. Percentage, multiplication, percentage. And this is going to be matrix multiplication. What is the answer, by the way, from your calculus? Any matrix multiply its transpose? Well, not necessarily. Well, we are one step away from that. I'll get to that identification matrix. That's the inverse one. But this is A multiply the transpose. So we have to basically it's multiplying this row to this column 1, 5, 9, 13, 17 and add them together. So the number is 5, 6, 5 and etc. And you can look at that. It's a 4 by 4. All right, then what is the inverse of a matrix? So the inverse of a matrix, in R, we show it by solve. Yeah, this name is not intuitive at all. So you expect to at least use the inverse function, call it inverse, but again, the author decided to use solve because we are solving for the inverse of it. So if I do solve A, oops, sorry. So for a matrix to have an inverse, we know that it must be a squared matrix. So A is not a square, it's 4 by 5. So we have to work with another matrix. Let's see what I have here. Okay, let's make a new matrix, call it Z. Okay, it's a 2 by 2 matrix, so it's invertible. We can solve for the inverse. So now if I do solve Z, this is the inverse of the Z. So and each matrix multiplied by its inverse is going to be identity matrix, right? So 1 0 0 1. Here's a question for you. How to create identity matrix in R? Google it. Use a Stack Overflow. There's a function, and then if you use that function, you can generate this matrix. All right. So the next object is going to be factors. And by the way, some side notes. Do you see that this R basics, there's a star strict here, and it's red. This is suggesting that this script has not been saved. If I save it, the color is going to change, and then there's no starter. So just make sure that once in a while you save your script, because if it is unsaved and I close the R script, open it, it's going to all you've done is going to be gone. So make sure that you save it very frequently. Okay, the factors. We are not going to use factors in the class, but quickly, what are the factors? Imagine, you have a vector, and this vector is something like this. These are apple colors: green, green, yellow, red, 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 green. Right? We assign it to a variable, call it apple underscore color. So if I just call apple colors, basically these are the colors, right? Now I want to make a factor out of these apple colors. So I'm going to call it factor apple. So the function, as you can guess, is factor. Give me the data. The data is apple color. Give me the levels. Level is red, green, yellow. Give me the order. Do you want to order them? Yeah, if you want to order them or not. But let's look at this factor. So the factor apple, if I click the factor apple, it says that, look at that. This is what is inside this object. Green, green, yellow, red, 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 green. And the levels are red, green, yellow. And we said order them. Red is less preferred than green, and green is less preferred than yellow. Does that make sense to you to order them based on color? Maybe yes, maybe not. Or even if it is yes, you don't like this ordering. You have to change the ordering, right? So say yellow, green. Maybe green is the best one, then yellow, then red. Again, this is just one example. Okay. Then if you have a factor, you can look at the number of levels. So how many levels here we have in factor? 3. So I have to, again, make sure that you don't only select this one. You have to select the entire line, or either select click anywhere. So there are 3 levels, and then you can change back the factors to numbers. So if I want to make it numerics, remember we had green, green, yellow, red, 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 green, right? I said that green is the best one, so it's going to assign 1, 2, 3. So if I say that take this factor and give me back some numbers, it's going to be 3, 3, 2, 1, 1, 1, 3, right? Again, we're not going to deal with factors in this class, so just, but there are huge applications, especially when it comes to visualization using some packages like ggplot. Factors are going to play a very important role. But for simplicity, we're going to skip the factors. All right, we are finally there. So let me pause the video, because this is a data frame, and data frame is something that we're going to use in this. Actually, let me continue with the data frame, and then I'll pause it, because I want to give this video a proper name. I want to call it different data types of variables in R. All right, so the data frames. If you have not followed whatever I told so far, which I don't want to say it's fine, but if you understand what are the data frames, you will survive the course. But again, you should practice or many times to become familiar with that. And to be honest, it's not that difficult. You know, you have TAs, you have me, you have Google. If you ever had any questions, please reach out to anyone else. Okay, so this is the most important one. What is data frame? Data frame is a type of object that you can basically put anything in it, right? So for instance, I want to come with a table. Think of it as a table. I want to come with a table that has 3 columns: student name, gender, and GPA. I'm going to use, a data frame. So for instance, when I say the student name is equal to a vector of PJ, TJ, MJ, remember, so what is this? PJ, TJ, MJ. I just want to make sure that these are the elements in the student name. Do you remember that I told you that in R we prefer to use this for assigning things to the objects? That's because within the functions we are using equality. Okay, so within the functions we use equality. Actually up there we used it a lot. So factors we use equality. Yeah, I forgot to mention it earlier. In the matrix we used equality, right? So that's why in R we prefer, when you're assigning something, we use this equation, this symbol. When you're using equality, it says that it's something within the function. All right, so let's run this line. I'm going to say that I'm basically, let's do it. I'm making the data frame. And tell me what are your rows. So I'm going to say that, okay, what is your column? So I have a column. Let's go with this one. Let's make a data frame. This is a column name, and these are the elements inside the column. Let's press enter. Okay, so it's a data frame, 3 observations, PJ, TJ, MJ, right? Let's add gender and GPA to that. So let's look at the data frame, right? Let's assign it to something called my data frame. Now let's look at the my data frame. So this is a data frame. It has 3 columns: student name, gender, GPA, PJ, TJ, MJ, male, male, female. Now these are the GPAs: 3.9, 4, 3.8, right? Now when you have it, again, these are must, because you have to learn these things, in very details, because we are going to work with them a lot during this course. Okay, so the functions that we use for data frames, it's not, I don't know why, what is this red? Okay, it's so those are hopefully self-explanatory. For instance, what is n row? Number of rows, right? What is the answer to this line? What are the number of rows in this data frame? The answer is 3, right? Number of columns, what's the answer? 3. Head is basically is asking for the head of the data frame. So this data frame is super tiny. There's only 3 rows, but if you use head and ask for the number of rows, you will get that specific number of rows. So for instance, give me the head of this 2 observations. That's it, PJ, TJ, right? All right, so let me show you the data frame one more time. So we are here, head, tail, as you can guess. Show me the tail. Again, this is a tiny data frame, and it doesn't make sense to do. By default, it will show you the 5 elements from the top and the bottom. If you use head, top. If you use bottom, tail, bottom, right? For Wooldridge datasets, we tend to use head and tail functions a lot, because you want to take a look at the head of the dataset, not the entire. Imagine the entire dataset has millions of records. You don't want to see millions of records here. First of all, your R may crash. Secondly, you don't want to see them all. You just want to see the first 5 observations and see what are the name of the variables, right? Okay, so this is tail. STR. STR stands for structure. So structure of the data frame. Tell me what is the structure. So this is a very important function. Tell me what is the structure of the data frame. So the structure of the data frame is something like this. So the answer is, it's a data frame. It has 3 objects with 3 variables. And look at that. It says the student name is a character, PJ, TJ, MJ. Gender, it's a character, male, male, female. GPA, it's a numerical. That's why, even though I told you that data frame is a thing that you should learn, but if you want to interpret things inside the data frame, you should already know what is character, integer, and double, vector, matrix, and you name it. Does that make sense? So they're all connected. All right. So, and then one last useful function. Again, throughout the semester, we're going to add lots of functions, but these are the basic ones. So this is the very, very important and useful one. Give me the summary of my data frame. So if I click, tell me the summary. It says that, okay, so your student name, because it's a character, it doesn't make sense to report the minimum, maximum, PJ, TJ, MJ. It doesn't make sense to report minimum, maximum. But if your variable is a number like GPA, then it makes sense to report minimum, maximum, first quintile, third quintile, quartile, and median, mean, and etc. Right? So this is a summary. It's a very good summary statistics of your variable. All right. Now let's extract information from the data frame. So this is also something useful. Again, let's look at the data frame. Let's extract information. So there are different ways that you can extract information. One way is using our friend bracket. Another way in data frame, which is easier, is using $sign. So as soon as I type my underscore, whatever is in your environment is going to be suggested here. So I have my data frame. Now, if I press $sign, see what will happen. When I press $sign, RStudio automatically understand that I'm talking about this data frame, and these are the variables inside the data frame. So if I only want to extract the gender, I click on this gender and then press enter. So male, male, female. If I want to extract something else, I don't know, the GPA. If I do $sign GPA, these are the GPA, right? I could have extracted right using brackets. So use bracket, then type GPA. I get the same answer output, but remember, there's a difference between this output and this output. Can you guess? Does it ring a bell? So the output of, if you use $sign for extraction, the output is a vector. If you use bracket for extraction, the output is what? This is a matrix. Okay. All right, so let's look at them here. This is a student name, and the student name shows as a matrix. Then you can say, you can extract it more, in a more customized version. So say that, okay, only give me the student name and gender columns, right? Student name and gender. And then extract everything but the third one. Remember, the third column was what? The third column was GPA. Everything but the third column. And again, you can say all the rows but the second row. All the rows but the second row. 1, 3. Does that make sense? All right. So let's stop the video here. Well, actually, let me scroll to the very bottom of this script, which is talking about the list, and then we conclude, then we come back to the while, for, and repeat operators. So the last type of object is list, and list is the most comprehensive collection of objects that you can imagine, right? So this means that you can put anything in a list. So let's make a list. Let's make an empty list. And as you can guess, the function is called list, right? So let's make an empty list and assign that empty list to something called my list. So I'm doing it something like this, right? So my list is an empty list. So if let me show the environment. So where's my list? It's a list of 0. So there's nothing in it yet, right? I can put anything in a list. So the extraction of a list, if you want to put, for instance, the first object in a list, you have to use 2 brackets. So I'm saying that put the string hello, the word hello, into the first elements of my list. So my list, 2 brackets, 1, and then put hello inside it. Then my list second element, it's a vector. My list third element, it's a data frame. My list fourth element, it will actually, let me ignore this one because we haven't covered the Wooldridge data set. Okay, let's stop here, right? So this is my list. Now, if I look at what's inside my list, look at that. It's a list of 3. So if I type my list and then press enter, see? So that, okay, the first element in your list is hello. The second object in your list is a vector. The third object in your list is a matrix. Now you may wonder, okay, now let's go beyond that. How can I extract this thing from a list? Pause for a moment and think about it. If it was a matrix, you know how to extract that, right? You say, okay, open close bracket, 2, 2, right? But this is a list. This is a third element of a list. So as you can guess, we have to do my list. Give me back the third element. From the third element, or from the third object, give me, I know that the third object is the matrix. Let me show it to you. This is the third object, right? Now if I go ahead and add something to that, from that, give me the 2 and 2. So what's the answer? 3.8. Okay, so this is how we extract things from a list as well. Okay, so list is also important because the output of the regression that they use in our models is going to come as a list. And if you ever want to extract something out of those regression outputs, you need to know how to extract things from a list. So this is also important. So all in all, it's about 55 minutes. So the takeaway from this video should be, you should understand how to work with different functions in a data frame, how to extract things from a data frame using $sign or brackets, what is list, and how to extract things from list. And the rest of them, I believe, were very standard and simple. If there's one thing that you can safely skip is factors. So it really doesn't matter if you didn't understand factor. But again, just do some self-study because these are really good investment for your own sake. All right, so let's finish this video. I'll see you in the next one.